Let's see an example of how to solve trig equations that are quadratic in form. Let's find all solutions to this equation here. Now let's begin by bringing the 1 to the left-hand side, which would give us 2 sine squared theta plus sine theta minus 1 is equal to 0. Now isn't this the same thing as 2u squared plus u minus 1 is equal to 0, where u is sine of theta? So it's quadratic in form. And how do we solve a quadratic equation? Well, we factor if we can. And the left-hand side here will factor. It factors into 2u minus 1 times u plus 1. Which means this will factor in the same way. Namely, it factors into 2 sine theta minus 1 times sine of theta plus 1. And now we have a product of factors equal to 0, which means either this first factor, 2 sine theta minus 1 is 0, or this second factor, sine of theta plus 1 is equal to 0. So let's solve each equation separately. So let's start with this first equation here. So case 1, 2 times sine of theta minus 1 is equal to 0. Or solving for sine of theta, we get sine of theta is equal to 1/2. Which means we need to find all angles theta whose sine is equal to 1/2. And let's recall our unit circle. Remember that the sine is the y-coordinate of the point of intersection of the terminal side of the angle and the unit circle. So looking over here in quadrant 1, we see that the y-coordinate of this point is 1/2, which corresponds to the angle of pi divided by 6. But also over here in quadrant 2, the y-coordinate is also 1/2, which corresponds to the angle of 5 pi divided by 6. So both of these angles will have sine equal to 1/2. That is, theta is equal to pi divided by 6, or 5 pi divided by 6. But what else? If we go around the unit circle 2 pi radians in either direction, we'll land on these same points, which means the sine of those angles is also equal to 1/2. So not only pi over 6 or 5 pi over 6, but any of their coterminal angles. And remember how we write this. Theta is equal to pi divided by 6 plus 2k pi, where k is an integer. Or theta is equal to 5 pi divided by 6 plus 2k pi, where k is an integer. So all of these angles will be solutions to this first equation here. Now what about this second equation? So case 2. Subtracting 1 from both sides gives us its sine of theta is equal to -1. Again, looking at our unit circle, we see that the y-coordinate of this point is -1, which corresponds to the angle of 3 pi divided by 2, which means the sine of 3 pi divided by 2 is equal to -1. But so is the sine of any of its coterminal angles. That is, theta is equal to 3 pi divided by 2, or any of its coterminal angles. That is, theta is equal to 3 pi divided by 2 plus 2k pi, where k is an integer. So our answer then is any of these angles or any of these angles. Any one of these values of theta will satisfy that original equation. All right, and this is an example of how we solve a trig equation that's quadratic in form. Thank you, and we'll see you next time.